Okay, so we're going to try to do something with this Insolation Angle Lab. Doing this on an iPad, so bear with me here. This is sort of new territory. So anyway, so first things first, you have your data sheet. You have your data. So the data, first off, is in the updates. So if you go to the updates up here, top left of the class there, or you just click on updates right here in the lesson plans. That should take you to the updates. I got to scroll down a ways because I got, like, for every post I make to you guys, I got 5 on here. So you go down and pick one of these. Well, depending on which one you've got. If you're third and fourth period, that's one I want to go ahead and do, but it's a different data set than the one I have for 6th, 7th, and 8th. Same process, though. So I'm just going to go ahead and download the data set here for 4th period. Let's see, download. That should go into my downloads folder. And then we need to open that. Now, if you kind of remember, you can't just go click on the data. It's just going to open the software. And you have to go to choose file to actually open the data. If you do not have this registered, double check down here, make sure it's registered. If it's not, go back to the lesson plans page. There's a link to a video on how to do that. I'm not going to do that right now. I just did it. There's a video posted. So we're going to go to choose file. Then you got to pick the file that you were trying to open. For you guys, it's probably in downloads. Or honestly, for me, it's the same file I uploaded from my Insolation Angle Lab here in 4th period. So I'm just going to open that one. That's fine. And it looks something like this when you get it open. Okay, so that's our data. So we have that. Now let's go find our data sheet, which honestly I've already got it downloaded. For me, I downloaded it's in my little work done together folder. 4th period, radiant energy, wrong lab, insulation angle, and then we'll open our data sheet. And the data sheet should be titled something like PSV 14 insulation angle. Now, for you guys, if you go to if you just go to the lab itself, well, you got to download it. And that's basically right here. Download that. It should go to the downloads folder. Then open it from there. If you have a paper copy, you don't have to worry about downloading it. So, all right. Okay. So still trying to get used to this, but if we're using the new preview program that's was in the last update, you actually have to go in here and open it that way. So we're going to run back through. So all I did there, it's kind of confusing now. So I've got a version of it that was open in the files here, but every time I go out of that, it closes down. So to keep it open, you want to go into the actual preview app, which looks like the little kind of a magnifier glass thing here. It's a weird magnifier glass. The magnifier is up here, and it's basically you set it over things to look at it. Anyway, getting sidetracked. So anyway, so this is the Insolation Angle Lab. We already set all this up. We had our 2 wood blocks, except for us, it was more along the lines of 25 degrees and 65 degrees, but that's okay. So go ahead and mark that there. But we set all this up. We already recorded all this, and it really got us down to number 9, actually. So we just need to get a little bit of data off of this. Okay, and then export a copy of it. So we got these 2 things we need to do with our data, 8 and 9. So we need to go and get our minimum and maximum temperatures just like we did on the Radiant Energy Lab. So we're going to go back to the data, we're going to view statistics, and we're going to get a minimum and maximum temperature for each one of those, and those are going to go right here. It's really the same kind of setup as the Radiant Energy Lab. So you got a minimum, a maximum, a delta T, so our change in temperature, and then we got some questions. So it's not too bad. So if we go back over to our data, we go down to our graph options down here in the bottom corner. Click on that or tap on that. Go to view statistics up here. And that should give us our statistics for it. Now, if you look down through here, you got the minimum right here, the maximum right here. And if you look at your color coding, the blue one is our 25-degree angle one. That's more the one that is flatter. The 65-degree angle one is the one that's more upright. So for 25 degree, we're going to actually put this in the 30-degree data. I'll probably mark it out and mark it as 25, but the minimum, 22 point, let's just round it off to 1 decimal place, 22.3. So if we go back over here, our minimum here, I said this was actually the 25 degree. This is actually 65 degrees. Okay, so our minimum for the 25-degree angle is 22.3. The maximum is 29.3. Okay, so we'll come here, maximum 29.3. And then for the 65-degree one, 22.3 degrees. Again, so it actually starts at the same value. Both these start at 22.3, which is good, and ends at 27.9, or that's our maximum. So 27.9 is our maximum temperature there. Okay, so that's our data. Now we need to export a PDF copy of that and then either attach it. If you're doing the digital copy, or if you did a paper copy, you can export it and just go ahead and upload that to Schoology, and then come back to your paper copy and finish everything else. So you should have something uploaded to Schoology either way. You should have either just the graph, or you should have the graph attached to the datasheet. So again, to export, and again, if you're not registered, this won't export as a PDF. At this point, I would export as an image and be done with it, but we're going to come up here to the name, so the file name. We're going to go down to export down here. Click on that. And then that gives you your graph. We're going to go to PDF here. So we clicked on PDF to bring up our PDF version of this, and we're going to say share PDF down bottom right corner. Give it a name, give it a place to live. Of course, it's going to cover up where I'm typing. There it goes. So Insolation Angle share should ask me where I want to save it or what I want to do with it here. So we want to save to files. Honestly, when in doubt, save to files. That way you can control where it goes and you might be able to find it later. So I'm going to call this work done together for mine. You should honestly probably have a folder set up for science. If you don't know how to do that, ask me later. So we're going to go to 4th period for this one. We're going to say Insolation Angle Lab and save. So I've got everything kind of organized to where there's a different folder for each class, then a different folder for each lab in each class. So. All right, so now we should have an exported copy. Now, like I said, if you're going to, if you're doing the paper copy, you can just go to Schoology and upload that. If you are doing the digital copy, though, you need to go back to the digital copy, which is what I'm doing here. We'll scroll down to the bottom, and we're going to attach that. So to attach that on the iPad in preview, you go down to the last page, This should highlight the page over here. There's three little dots right there. Click on that. And you can say insert from file. And then you've got to find, so when you go Insolation Angle Lab, there we go. That's the one we're looking for. So that's so we're going to the Insolation Angle Lab PDF here. Let's see if that's the right one. That's the right one. That's what it's supposed to look like. Okay, so now we've got our data, all except for our delta t, and we've got our graph attached. So we're kind of done with the data. So we actually did these two up here. So we can just kind of check. Those are good. Okay. Now we can come on down here and finish some of our questions. So first bit, calculate the temperature change, delta T. Delta T is always a change in temperature. Delta means change. That little triangle is a Greek delta. But anyway, for each angle by subtracting the beginning or minimum temperature from the final or maximum temperature. So again, delta T is T max minus T min, or T maximum minus T minimum, and then record that in the data table. Okay, so for the 25-degree one, we're going to take we're going to do old school math here. 3 minus 3 is 0. Bring our decimal point down. 9 minus 2 is 7. And then 2 minus 2 is 0. So our delta T here is 7.0 for the 25-degree angle one. Then for the 65-degree angle one, our final temperature was 27.9. Our initial was 22.3. Oh, do your math. So 9 minus 3 is 6. 7 minus 2 is 5, so a delta T there of 5.6. Okay, so that's our delta T then. Now, if you did it on paper, yeah, yours should look something like this. If you're doing this digitally, I mean, you could actually write this in as something like, you could type it in 27.9 minus 22.3 that way. Okay. I'm not going to go to the trouble of making text boxes because this video is going to be long enough as it is. Now, temperature change is an indication of the amount of radiation received by a surface, at which angle was the most radiation received. So in other words, which one had the higher temperature. And we could say our 25-degree angle. And that's because okay, so higher delta T, higher change in temperature. All right, at which angle was the least radiation received? Well, that's going to be the other one, so that's going to be our 65-degree angle. And you know that because there's a lower delta T. Again, when you're doing any of these labs, you want to try to relate your answers back to the data itself, not just other things you know. You got data from the lab, refer to it, use it. Which angle closest represents the northern hemisphere, which is where we are, of the Earth in the summer. So the 25-degree angle one is more like us in the summer. Let's say 25 degrees equals summer. .65 degrees is us in the winter, because in the summer the sun is more direct, and that's our angle that was kind of like that. The 65-degree angle was the one that was a little more like this, okay, a little steeper. So the sun's rays, when they come in the summer, they are hitting more directly than they are in the winter. Then at what time of day do we receive the most solar radiation, and why is that? Well, this week you have to kind of go back to things we know, but if you think about the sun going across the sky, when it's directly overhead, you're going to get the most solar radiation, and that's going to happen at noon. So noon, because sun, man, my handwriting's getting worse. So we're going to say noon because the sun is directly overhead. Don't forget your why here. Okay. And then what is the best location and position for windows of a solar home in your area? In other words, a house that you're going to heat by sunlight. This one's a little trickier to answer, but if you kind of think about where we are, the sun is usually in the southern part of the sky, so you're going to want your windows facing south. So you're going to want south-facing windows. In our area. And that's because the sun is in the southern part of the sky. So the sun is kind of always coming from the south. Okay. So south-facing windows because the sun is in the southern part of the sky, so the sun's coming from the south. Let's see, what are the colors and materials on which the probes were placed to affect the results? Okay, so we didn't actually do that. We kind of know from our previous lab, though, that black absorbs more than white. We actually used, really didn't use any color material. I just kind of put these right on the wood block, so it was a lighter colored wood. And then other extension, while the Earth's distance from the sun is not an important factor in our seasons, it does provide us with ideal temperatures for life. Design an experiment to test how temperature changes with the distance from the same simulated sun. So here, basically, all you could do, if you wanted to, you could design an experiment where your wood blocks are like here and here, and then maybe you test the sun or test it with the lamp at this height, and then maybe test it again with the sun at this height. So you could actually do it from different distances. That's all that experiment would actually be. But again, don't have time to do that, especially with snow days. So that's really it. So you got your data. You should have your data file you can download. And again, you may have to play around with this a little bit to get it to work. But download the data, get your minimum and maximum from it, calculate your delta T, answer your questions, and then you should have a copy of that data attached. So that's it.